Hello guys. A while ago, I began work on a computer in Melon Playground. I never finished it, but recently, I felt like making another computer. However, I decided to challenge myself. I'm quite good at programming. Normally, I would use Scratch, but I decided that it would be funny to use Desmos. If you don't know what Desmos is, it is a graphing calculator that has been used to make many things, but I haven't seen a CPU yet. But firstly, we must figure out how we are gonna do this. Computers are made of logic gates. There are 8 different logic gates. The buffer doesn't do much. It essentially acts as a delay. The NOT gate inverts the input. The AND gate outputs a 1 if both inputs are 1. Otherwise, it outputs 0. The NAND gate is the opposite of the AND gate. The OR gate outputs 1 if at least one of the inputs is 1. The NOR gate is the opposite of the OR gate. The XOR gate outputs a 1 if only one of the inputs is 1. Otherwise, it outputs 0. The XNOR gate is the opposite of the XOR gate. But how do we implement these into Desmos? For each gate, we need an equation for the output. We know that there are a max of 2 inputs in the gates. We can define the inputs as I0 and I1. We can define the output as O. The buffer is very simple. The NOT gate is also quite simple. It can be simplified to this. The AND gate is this. NAND is short for NOT AND. So we can stick a NOT gate on the output of an AND. An OR gate, NOR equals NOT OR. An XOR gate is complicated, but this works, as NOR equals NOT XOR. It went off the screen. So shall we start making something? The first component we will build is the OLU. OLU stands for Arithmetic and Logic Unit. The OLU I will build will be 4 bits. This means that the inputs are made of 4 bits each. The diagram below shows an adder. The 2 dots labelled I are the main inputs. The one below that labelled C is short for carry. It allows multiple adders to be chained together. The C on the right is the carry out. Finally, the O is short for output. I will link 4 of these together to make a 4-bit adder. The inputs in red are the I0s from the previous. Likewise, the greens are the I1s. The blues represent the carrying. The purples are the outputs. The orange is the carry out. We can then put this into the OLU. This is the layout of the OLU. The blue path allows us to change this into a minus operation. The gold path checks 4, as the answer is 0. The dark green is the carry flag. For a more in-depth analysis, check the video in the description. So let's implement this into Desmos. For this episode, I will make a simple adder. We can split this diagram into 3. The input, the logic, and the output. We can make these into folders in Desmos. We can easily add inputs. The logic is more complicated. I've labeled them with the line numbers. I then implemented these gates. For the outputs, I used points. The height changes depending on the output. Here's the adder functioning. I'm now in Desmos. I've ran out of songs. But anyways, if we have only one input on, only the output is on. If we have 2 on, only the carry is on. And if we have all 3 on, both turn on. Here's the logic and the output. So that's cool. So, we now know what computers are made of, how I implemented this into Desmos, what an OLU is, and how I put this into Desmos. In the next video, I will build the rest of the OLU. Thank you for watching. Okay, bye now.